A closed figure formed by three intersecting lines is called a triangle. A triangle has three sides, three angles, and three vertices. Two figures are said to be congruent if they have the same shape and same size. In this chapter, we will study about those figures which have the same shape but not necessarily the same size. In this chapter, we will discuss the similarity of triangles and apply this knowledge to prove the Pythagoras theorem. In this chapter, we will study the following concepts: congruent figures and similar figures, similarity of triangles, criteria for similarity of triangles, areas of similar triangles, Pythagoras theorem.
Congruence of triangles. Congruent figures. In geometry, two figures are congruent if they have the same shape and size. This can also be explained as two sets of points are called congruent if and only if one can be transformed into the other by an isometry, that is, a combination of translations, rotations, and reflections. For example, the pair of figures shown here are symmetrical in shape and size. Congruent lines and congruent angles. Two line segments are congruent if and only if they have the same length. For example, lines AB and LM both have equal length and they superimpose each other. Two angles are congruent if and only if their measures are equal. For example, this boy folds both the hands to a same stage, so the angles formed by his hands are congruent. Two circles are congruent if their radius is of equal length. For example, the circles shown here are of same radii, thus they are congruent. Two rectangles of same length and same breadth are congruent. Let the length of rectangle ABCD be 6 cm and its breadth 4 cm, and the length of rectangle PQRS is 6 cm and its breadth is 4 cm. Two squares are congruent if their sides are equal. For example, the squares shown here are of same sides, thus they are congruent. Two triangles are congruent if they are equal in all respects. In the above two figures of the triangle, AB is equal to PQ, BC is equal to QR, AC is equal to PR, and angle A is equal to angle P. Angle B is equal to angle Q. Angle C is equal to angle R. Thus, triangles ABC and PQR are equal in all respects. Therefore, triangles ABC and PQR are congruent. Similar figures. Figures with the same shape but not necessarily the same size are called similar figures. In this animation, the first T-shirt overlaps the second T-shirt, and the two T-shirts overlap the third T-shirt. So, the three T-shirts have the same shape but not the same size. Result: two polygons with the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Relationship between congruent and similar figures. All congruent figures are similar figures. In the animation, we have three congruent squares. These squares are also similar because they have the same shape. Similar figures need not be congruent. In the animation, we have three circles that are similar as they have the same shape. these circles are not congruent because they do not have the same size. Now we know that two figures are similar if they have equal corresponding angles and proportional sides. What happens when the sides are not in proportion, but the angles are equal? Consider a rectangle and a square. Here, both the figures have equal corresponding angles, as all the angles are right angles. Upon overlapping the figures, we come to know that they are not similar, for the length of rectangle is not proportional to the length of the square, because the length of the rectangle is more than its breadth, whereas the length and breadth of the square are equal. The two figures are not similar. Thus we can conclude that two figures are similar if and only if their sides are in proportion and the corresponding angles are equal.